Then we will talk about non-invasive healthcare system. Then what are the signal processing technique will be available, and how the methodology can be developed for improvement, diagnosis of any healthcare system.
So slides are not moving. Still, it is on first slide.
Oh, sorry. Now it is.
Still not, sir.
Just a minute.
Okay, sir. Okay, sir.
Again, I will try and share.
Sure, sir. Sure, sir.
Now it's visible.
Yes, sir. Yes, sir.
Moving.
Yes, sir. Moving.
Just in full screen. Now it is.
Fine, sir. Fine.
Yeah. Thank you, Sachin. Thank you. So now we will take some example for a diagnosis of any system, then what methodology I have adapted, then result, then conclusion, then references. So as we already know, nowadays healthcare is a very essential and high cost sectors, or it is growing faster than our economy. So and the expenditure is day by day is increasing due to the population growth, aging, and disease incidence and prevalence. And it is also the expenditure is increasing because the demand is also increasing in the health services. Then the rise of the prices.
Still, it is on second slide. Content one slide.
Oh, I don't buy.
Sometimes there is a glitch. It may stuck.
Now you see.
No, sir. Still, it is on second slide.
Not moving.
Not moving, sir.
Just a minute. Again, I will try.
Yes, sir. Yes, and sir, not to use the full screen mode. Simple, just normal PPT is also fine. Normal mode also, because what I feel that when you switch to the full screen, at that time it is not moving, and normally it is moving.
Now it is visible.
Yes, sir. Visible.
Now it is
moving also, sir. Fine.
Just you see now.
Yes, sir. Yes, sir.
Now it is visible. Third slide.
Third slide, sir. It is the introduction slide.
Fourth.
Now it is not moving, sir. It is still at third slide.
Okay.
So sir, can you can we try to just make a PDF of this presentation and then share?
Yeah. Just a minute.
So it is moving. Sometimes it is lagging and sometimes it is moving. Now I can see the ninth slide. Use of robotics to deliver treatment, robotic surgery.
Okay. Now it is visible.
Sir, it is still not visible.
Okay. So entire screen I will share.
Yes, sir.
So now I think it is visible.
Yes, sir. It is visible.
Moving
also fine, sir.
Everything is fine now.
Everything is fine now, sir.
Yeah. Thank you, Sachin. Thank you so much. So So like the rising of the prices in healthcare sector may be due to the pharmaceutical cost also. So the healthcare system are made a multiple information processing tasks like screening and diagnosis, which can consist the classification of patient cases through the information given by the examiner, investigator, and previous history. The another processing task is the treatment and monitoring task, which comprise of planning, implementation, and managing the specific action for treatment and monitoring of that particular task or diseases. The third processing task is managing a healthcare system into also a very data-driven task, since a policymaker and manager need to optimize, maintain, and modify and allocate resources to the health system. So these type of processing, we required some machine learning algorithm. So in short, we can say that the healthcare sector comprises many decision-making tasks in a diagnosis purpose, in a treatment or monitoring purpose, and also in a prognosis purpose, we required some decision making. On these decision making tasks, machine learning and computer program are capable to solve this problem, and this type of problem can be solved and learned by the like a human brain. So here we can use a machine learning algorithm when we require some decision making. So machine learning is nowadays an exciting area for development of computational approach for automatically find out the sense of that particular data. From the sensing of that particular data from the organ, we can go for a diagnosis, or we can find out the physical activity of that particular organ. What are the advantages of machine? It can retain the information, become a smarter over the time. Machine is not susceptible to sleep deprivation, distraction, information overloading, and the short-term memory loss. So these are the advantages to use machine learning approaches. When we will talk about the machine learning in healthcare, so there are two different type of branches. One is known as virtual branch, second one is known as physical branch. So these are the few advantages, like highly repeated work, we can use machine or machine learning techniques. It also empowered our doctor to help the fast or more accurate decision making. It can augment and professional to offering that expertise and assistantship. It can also replace personnel and staffing in medical facilities, particularly in administrative functions. It can also manage wait time and automatic scheduling of the patients. If we talk about the virtual branch, so the virtual component is represented by the machine learning algorithms. So like there are three type of machine learning algorithm. One is known as unsupervised machine learning algorithm, where the ability to find out the pattern of that particular state. Supervised means classification of prediction algorithm based on the previous example. We already in the supervised learning, we required some prior information or prior data to train our model. Third is known as reinforcement learning. So what are the benefits of machine learning using in a healthcare system? So machine learning can definitely assist the physician. It can use for the clinical decision making. It can provide a better clinical decisions, replace human judgment in certain functional areas of healthcare like radiology, because radiology by visual inspection you need to find out whether the person having a disease or not. By using machine learning, you can that algorithm can assist the neurologist. This type of machine learning algorithm also can be updated from the latest information which can be published in a journal or some clinical practices. The machine learning algorithm also, one of the advantage, it does not differentiate within the experienced and fresh clinician. Like suppose new information, like the old doctors, they don't want to adopt new technology. So this is a big problem, and the fresh doctors do not have that much experience, so that by visual inspection or by investigation they can predict. So this time machine learning can be useful for both the type of clinician. It also available in 24/7 availability of expert. It can use for the early diagnosis based on the prior conditions, prediction of the outcome of the diseases, as well as treatment. That also can be used for prediction as well as treatment. Both purpose it can utilize. Feedback on treatment, whatever treatment is going on, how the reaction, how the treatment process is going on, that also can be monitored by machine learning algorithm. Yeah, reinforce pharmacological management, also machine learning can be used. It can also reduce the diagnosis and therapeutical error, increase the patient's safety, and use cost saving associated with use of machine learning algorithm, because machine learning is algorithm is very cheap. It can save use cost of diagnosis or treatment. When we will talk about the physical branch, so physical branch like nowadays tele robotic technologies in through IoT they are using. So in that particular branch comes under the physical branch, like in physical object, medical devices, sophisticated robots which can use for the delivery of care, and robotic surgery also a part of physical branch, where through machine learning algorithm some hardware can be used. So that come under the physical branch of machine learning. So like robotic surgery and monitor the robot, monitoring through robot is also come under the physical branch of the machine learning. So if we talk about the advantages of machine learning in healthcare, so the treatment of diseases are done before they can get out of the hand, because the patient are continuously monitored and the caregiver or provider can access the real-time data. And it also improve the disease management. So the person, whenever the disease will come, so it can be easily managed. The other advantage is the automated data and smart monitoring, which can control by the device connected with the IoT, and decision are made easily based on the deep analysis and reduce error. The patient monitoring is done by real-time basis, so significantly cut down the unnecessary doctor visits, also cut down the hospital stays. This can be reduce the cost of the patient. The fourth one is connected healthcare enabled and caregiver to get access to real-time information. When the patient is continuously monitored and the decisions are taken properly, this can help and provide timely care of the patient, which can be outcome will be the improvement of the treatment, will be very efficient way it can be treat out. So when we will talk about non-invasive healthcare system, so first we will try to understand what do we mean by the non-invasive healthcare system. So non-invasive means when we are taking the data from the surface of the body. Okay, invasive means some data, something we are inserting in the body and we are taking a data. That time it is very difficult to use machine learning algorithms. Okay, so when we are talking about the application of machine learning algorithm, so non-invasive healthcare system machine learning algorithm can be utilized. Non-invasive means the sensor can be put in the surface of that particular organ, then the data can be acquired, then this particular data can be processed for management of that particular disease. Okay, so in this practice of medicine, there are four primary practices. First is known as diagnosis, then prognosis, then treatment, then prevention. So here I am taking a one block diagram. So here first is known as data acquisition. Like in supervised condition, we require the data. Data means suppose you want to diagnose some disease, so which particular organ is responsible or which particular organ is affected by that particular disease. So from that particular organ, we need to acquire the data. Data means it may be a signal, it may be an image, it may be any type of information that known as data. Okay. Then from the data, we need to extract some useful information. That information we can find out by applying some signal processing technique. So there are so many signal processing techniques. Which particular technique will give you the exact information of the data and or how the information by using the signal processing technique, how we can extract that particular information so that that can be useful for diagnosis of that particular disease. Then the third part is known as features extraction. So features extraction means that particular information in the form of numeric value. Then these features can be used in some machine learning and classification algorithm where we can go for training, testing, and learning part. So in the first, what type of signal processing technique is available? So in engineering, basically we talk about the Fourier transform, Laplace transform, jet transform, or DFT. But these transform, whatever transform we learn in the engineering, These type of transform only useful for stationary data. Stationary means it has only sinusoidal component. But when we will talk about any real-time signal or any practical signals, so all are in non-stationary in nature. For dealing these type of non-stationary nature of signal, we required some classical methods which can provide more information of that particular signal. So like previously we heard about the transform. So transform is nothing but it's a mathematical operation which can convert a signal into a one domain to another domain, or it can map to one domain to another domain. Some of the application can easily solve by using this transform, like differential equation, convolution property, and it can reduce the compression and storage in the memory. So when we will talk about the Fourier transform, so for sinusoidal signal, Fourier transform work properly. Even though you have a mixture of these three also, then also it will work properly. But if the frequency is varying with respect to time, then this Fourier transform will not work. So that is the problem. So if you see the images and the signals, these are the where the frequency is varying with respect to time, then the Fourier transform will fail. Then some classical methods came in the existence, which is known as time frequency analysis method or decomposition methods. So this is STFT, which is basically a piecewise Fourier transform. Means here the one window is introduced, and based on this window, we are saying that in that particular window, your signal is stationary. Then in that particular window, the signal is, we are converting by using e to the power minus j omega t is basis function. Based on that, we are converting that particular signal into a time frequency domain. So this is known as STFT. This is one example of speech signal. So this is the one signal, and this is the STFT of that particular signal. Then after STFT, in STFT there is a problem. Which particular window will give the better analysis? Which particular window we can use for find out that particular STFT? Because if your time localization is good, if your time, the window having a low time, means the time span is less, then your frequency span will be larger. If your time response, time window span is larger, then your frequency response will be less. It's mean if your time domain window is have a good resolution, then frequency having a poor resolution. If time domain you have good resolution, then frequency domain your resolution is poor. So this is the problem in STFT. So as you can know Heisenberg principle, if your time span, time resolution is increasing, then automatically your frequency response will be poor. If your frequency response is good, then time resolution will be poor. So in time frequency domain, we need to find out the optimize how, in which particular condition, which resolution we need good, which resolution we need bad. So based on that, we need to sacrifice which particular application. It's very signal to signal and application to application. So now the another transform came in the existence, which is known as wavelet transform. In STFT, what we are doing, we are taking a sinusoidal as a basis function. Now the wavelet can be used as a basis function to model that particular signal. Okay, so wavelet, what is the difference? Sinusoidal have a infinite span, but the wavelet has finite span to model that particular signal. And another property of wavelet transform, it used for multi-resolution property. Multi-resolution means for entire duration of the signal, your wavelet will, the span of wavelet is change. According to our need, it can that wavelet have capability to it can change the span of your basis function. So this is the formula for wavelet transform. So here this S is known as scaling factor, tau is known as shifting parameter. Based on this scaling parameter, the span of wavelet, the basis function is changing. Okay, so that's why the wavelet transform known as having a multi-resolution property. So in this you can see here, if the value of S is less, here for all time the value is 0.1. Now after, when we will increase the value S is 0.5, then the time domain span will increase of that particular wavelength. So this way we can say that if we will go for time domain analysis, then we can extract only time information. If we go for frequency domain like FFT, then we have only frequency information, but that particular frequency, which time it is available, that we cannot find out. Then if we talk about the STFT, so STFT we can find out the time frequency plane, but the resolution is always constant. Even in a low frequency or high frequency, your resolution will be constant. But wavelet having a multi-resolution property, so based on that, if the signal having a low frequency, that time the time resolution is good and frequency resolution is poor. This way, comparatively, we can find out in which particular band your response will be. In the time domain is having a good resolution and frequency domain having a poor resolution. So so there are plenty of application of wavelet transform. Like this is the signal, then how we can find out the wavelet transform. So now after that wavelet transform, the whole signal processing is divided into a two part. One is known as decomposition, second one is known as time frequency representation. So when we will talk about the decomposition means the signal having a mixture of multi components. Okay, now what we are trying to do, by using some decomposition technique, we are trying to decompose a signal into a different bands. Okay, so like here DWT is the discrete wavelet transform, where the wavelet, we need to fix some wavelet, and this wavelet will divide your signal into a two parts. One is known as approximation coefficient, second one is known as detailed coefficient. So approximation coefficient means low frequency signal. Means suppose in any, if your signal having a frequency 0 to pi, then in the first level your frequency will divide into a two part. The approximation coefficient having a frequency 0 to pi by 2 and detail coefficient having a frequency is pi by 2 to pi. Then it can be further divided into a different bands. Okay, so like this is different band. So whenever you will increase the level, then your band will increase. So like here the frequencies again it will divide 0 to pi by 4 to pi by 4 to pi by 2. So now this is the decomposing your signal into a different bands. So this is known as discrete wavelet transform. There are the few wavelet commonly used like Dauchi wavelet or Haar wavelet. So when we will talk about application of DWT, it can use various applications like compression, denoising, features extraction, discontinuity detection. Also it can use for biological data processing, finance data processing, and this is the example of compression. Then this is for ECG compression. This can be used for denoising purpose. This is the example of discontinuity detection using DWT. Now CWT is representing the same signal you are representing in time and frequency domain. Means what time, what frequency component is present, that you can find out by using continuous wavelet transform. After that, the Cohen can come in the existence. Then he given a different theory in the time frequency domain. He says that STFT and wavelet transform is linear transform. Okay. Then the new transform time frequency domain came in the existence, which is known as Wigner-Willy distribution. Wigner-Willy distribution, your signal using a cross correlation property. Okay, means like in wavelet transform, you are taking a wavelet as a basis function to convert your signal into a time frequency domain. But in WVD, you does not require to take any other basis function. Your signal will help work as a basis function. Means this is the shifted version of your signal will used as a basis function. So that is known as Wigner-Willy distribution. So this is example of Wigner-Willy distribution. So Wigner-Willy distribution, this is the this is the signal and how the Wigner-Willy distribution will look like. So after that Wigner-Billy distribution, there are some other time frequency techniques or distribution came in the existence. There like SPWBD, Choi Billiam. There are so many so many time frequency came in the existence. In the decomposition side, after wavelet transform, empirical wavelet transform came in the existence, where we need to select some boundary and filters. Then TQWT came in the existence in 2012. Then FAWT came in the existence, which required tuning, selection of tuning parameter and mode. Then variational mode decomposition came in the existence, which generates the noisy mode. It also suffering from the mode mixing problem. Then RQA technique came in the existence. Then 2007 empirical mode decomposition came in the existence. So these are the, till now, these are the signal processing technique which can be useful for decomposition purpose, or your signal can be represented into a time frequency domain. Okay, now we will take some example how we can develop some diagnostic system. So here I am taking one example. Through EEG signals, we want to diagnose some disorder which is known as epileptic seizure. Clear? So how we can, the first thing we require, first we need to learn which particular organ is affected from that particular disease. So like epileptic seizure, our brain portion will be affected. Clear? So for brain activity, how we can measure that? We can measure by using a one signal which is known as EEG. So EEG is electroencephalogram, which measures electrical activity generated by neurons in a brain. Okay, so EEG provides, or EEG signal is a valuable clinical tool for investigate physiological and pathological states of human brain. But the quantitative analysis of EEG signal is challenging because it has complex and irregular nature. It does not have any shape. Okay, and it has non-stationary nature. So visual scanning of EEG signal is very challenging because it's a time consuming, it may be inaccurate, complex, subjective judgment, it may be human error. Sometimes it will look like the person having a seizure, but the person do not have any seizure. It's also trained by the it also performed by the trained professional. So this is a one problem. So what is our requirement? We require some machine learning or the technique where we can identify whether the person having a seizure or not, or when that seizure is occurring. Okay, for this, the database, we required some database. Which type of database we required? We required a database where the EEG signal, the person having a seizure and person do not have the seizure. Okay, now here there are two type of diseases. What type of diseases? Suppose the person having that disease continuously. Once the person having a disease, then it is affecting continuously. Sometimes diseases come for certain intervals. What is my point? There are two type of diseases. Like suppose some organs is affected permanently. Clear? Or through that particular signal or images, you can diagnose the disease. But some of the diseases only come for that particular time duration. After that person feel normal, then disease will suppressed after taking some medicine or some extra activity. Got it? So there are two type of diseases. Clear? So suppose if the continuously the disease is present in that particular patient, clear, then the problem known as classification problem. If in that particular signal for that particular event you are trying to find out, then it is known as detection problem. Okay, so there are two types. One is the diagnosis where we require some classification. Another is the detection where you require some threshold, the person having that disease on that particular time duration or not. Clear? So now for database, the database is available in PhysioNet. So in this particular database, there are 5 different types is present. Z is belongs to EEG signal for eyes open condition. O belongs to EEG signal, I is closed condition. N or F belongs to seizure-free class. Seizure-free class means person previously having a seizure, but when the signal is acquiring, that time person do not have that particular disorder. Okay, so that condition known as N or F condition. As when the person having that disease, that time that signal is acquiring. So that is known as S class. Each group having 100 signals. The duration is 23.6 second duration. EEG were recorded from the 128 channel amplifier system using common reference. Sampling frequency is given 173.61 hertz. And here in our experiment, what we have done, we have combined Z, O, N, F class known as non-seizure class, and one group is known as seizure class. Now my work, we need to classify these two different groups. In a one group, we have a 4 different Z, O, and F, and one group we have only seizure class. Clear? Now what we have done, now what frequency component will be responsible to occurring that seizure, we don't know. Clear? So what we need to do, we need to decompose a signal into a different band. So we have chosen an empirical mode decomposition. Why empirical mode decomposition? Because it's a suitable for non-stationary signal processing technique. So it's an adaptive method. It does not require any basis function. It's a data dependent method, does not require any condition of stationarity or linearity, and it decomposes a signal into a different narrow band intrinsic mode function. That intrinsic mode function can be represented by AM/FM models. So that's why we have chosen a EMD. So how EMD works? So as what Fourier says, Fourier says that the signal can be represented in the form of sinusoidals. Okay, but if your signal is periodic, then it can be, he has represent the signal into a Fourier based on Fourier series. But if signal is aperiodic, then he has done through transform. Okay, so the same property EMD is following. When we will say the signal is stationary, so the complete data set and number of extrema and number of zero crossing must be same or differ at most by 1. Then we can say that this is the first condition to satisfy to find out the IMF. The second condition, mean value of envelope defined by the local maxima and local minima is 0. If your signal is following these two conditions, then only you can say that this is your IMF. Clear? What we are trying to do here? We have EEG signal and we want to find out the band of that EEG signals. Okay, so through EMD, we want to find out the sinusoidal component from that signal. Okay, so these are the two conditions for find out any sinusoidal component. So how EMD works? Suppose this is your one EEG signal, clear, and we does not have any prior information of the signal. So how EMD will decompose a signal into a different band? So this is and we does not have any basis function. Then this first we will extract the maxima, then interpoline these maxima, then minima, then interpoline these minimas, then we will take average of them. So if this average is the mean of this envelopes is not 0, then we can say that this particular signal do not have a IMF. It does not have any IMF. Clear? So how we can extract the IMF from the signal? What we will do? We will subtract that average signal from the original signal. Clear? Because this is the reminder. This is the extra from the signal to make your mean is 0. So what we will do? We will subtract this thing from the IMF. So now this signal we will get. Again we will check the same property. Then interpoline, then take average, then again average is not 0. Clear? Then again this is the extra, then the pink one is we will subtract from the black signal. Clear? Then again you will get this signal. So this process till if your IMF will not become 0. If your IMF will become 0, then you can say that this is your first IMF. But when we are going for computer technology, or we are using some software or some MATLAB or Python or any other, for that software 0 means exactly 0. But here you can see that after so many iterations, 0 is not coming. Maybe 10 to the power minus 10 will come, but 0 is not coming. Then your programming will not stop. It will not say this is your first IMF. So where we will stop? So the new stopping criteria is came in the existence, where they said that if the 0.01% amplitude is coming in the mean, then you can consider that as a 0 mean. Okay, means 1% of amplitude of your original signal. Then you can say that if your mean is 0.001, then you can say that this is your 0th mean. Then you can say that this is IMF. Clear? That's why we are saying narrow band. If it is exactly 0 will come, then you will get sinusoidal, exact sinusoidal, which have only one frequency. But this achieving this 0 is very difficult, and it will computationally it will give the more iteration. So that's why the some criteria we have to fix it. So now Hilbert has fixed that criteria, which is known as Hilbert, or Rowling also improved that criteria. Based on that, we can say that this is your IMF. Clear? Which is not a sinusoidal, exact sinusoidal, but it look like a sinusoidal, which you can say that narrow band signal. Clear? Now, after getting this first IMF you remove from the original signal, then you will get second, then third IMF, then fourth IMF, then fifth IMF. This process will continue till you will get DC component or monotonic function, which will be like it does not have any extrema, it does not have any minima, it does not have any maxima. Then you cannot find out any envelope. Then you can say that now here your method will stop. So for this particular application, we got 8 IMFs and 1 residue. Okay, now here you can see the IMF one having a high frequency as compared to other IMF. As the IMF is increasing, your frequency is decreasing, means IMF 8 is low frequency component and IMF 1 is high frequency component. Clear? So this process is known as empirical mode decomposition. So this way your signal can be represented in the form of IMFs plus residue. Clear? So what we have done till now, we have decomposed our signal into a different bands. But here we don't know which particular band is responsible and which particular band we can differentiate the person having a seizure or not. Clear? Because if we take original EEG, then we do not, all type of bands are available. Then it is very difficult to find out this particular activity. So what we have done, we have decomposed. After decomposition, we have divided a signal into a different bands, but we don't know which particular bands that particular activity is occurring. Clear? So now after that, we have these IMFs are real signal. So if you take Fourier transform of the signal and find out the instantaneous frequency, then it will come 0. Why it will come 0? Why it will come 0? Because when we will take real signal, then it has reciprocal of the same frequencies repeated, both sides. Clear? Negative side as well as positive side. Clear? So when you take average, then it will become 0. But when you will go for MATLAB or some other tool, then there is no negative frequency come in the existence. So what will come? Your repeated frequency will come in the existence. Clear? So when you will take instantaneous frequency, so that will be you may be get misinterpretation, whether it is actual frequency or it is reciprocal frequency. So what we need to do, we need to go for Hilbert transform, or we can say that analytic representation of IMFs. After representation of analytic representation of IMF, you will get only positive side frequency component. Clear? And your spectral density, power spectral density will get double. Clear? So now this analytics signal you can represent by 80 e to the power j phi t, where the amplitude modulated and phi t will give you the frequency modulated signal. Means this ZT, which is known as analytic representation of IMF, can be represented by AM FM model or AM FM signal. After that, we have extracted features. These features known as beta AM, beta FM. What do you mean by the beta AM, beta FM? So like if you find out the bandwidth of that signal, then we cannot find out which the contribution of the bandwidth, how much contribution due to amplitude and how much contribution due to frequency. So I come up with experimentally, I have come up with the two formula. One is known as beta M, second one is known as beta FM, which can tell you how in that particular IMF, how much bandwidth due to amplitude and how much bandwidth due to frequency. So this way we can calculate two features, beta M, beta FM. But for any application, there may be any features. But we need to find out whether this features is useful or not for identifying or discrimination of that particular activity or not. Clear? So like here, I have used two features. After getting these features from all signals, whatever signal we have used in a database, from all signals we have to process the same thing. So now after calculating bandwidth, what we have different beta AM, beta FM of different IMFs. Now there are two questions. First question, which particular band is useful for identification or classification of seizure? Second question, whether these features are useful or not. Clear? For this purpose, first we will see this. For this purpose, we have to go for some statistical test, which is known as ANOVA test, which can find out by Kruskal-Wallis or box plot. Okay? For this, we can identify whether this particular IMF or features are useful for discrimination or not. Clear? So here you can see this is beta AM features. This is for seizure class. This is for non-seizure class. For first IMF. This one is for first IMF. This is only for first IMF. Clear? So like this is showing activity of your seizure or non-seizure class for first IMF. It has 400 beta AM from non-seizure class. It has 100 beta AM for first IMF for seizure class. Why? Because it has data for 400, it has data for 100. Now how to do Kruskal-Wallis? Kruskal-Wallis we can apply if both the classes have same population. So what we need to do, we will repeat this population into 4 times, because when you are repeating something in the same times, then your statistical property will not change. Clear? So there is, for repetition, there is no problem in a statistical test. So after that, we can find out key. Suppose if this blue box is disjoint, clear, means 75% of data your disjoint or discriminable. Clear? This is the based on the probability. Clear? Now based on, if this is disjoint, then we can say that this can be useful. This beta AM features of first IMF can be useful, but we cannot conclude that it can. After the classification, it also used. But here we can find out the probability that this will be useful. Clear? So you can see here the first 4 IMF have capability to discriminate these two classes, but IMF 5, 6, 7, 8 do not have capability to discriminate these classes. Clear? Same. Another thing we can find out, that beta AM is higher in case of non-seizure class. Okay, but for seizure class it is less. Now, beta FM, if we talk about the beta FM, so beta FM also same. It also have discrimination capability. First 4 IMF, but others IMF do not have discrimination capability. It means only first 4 IMF with beta AM, beta FM have a capability to classify, to discriminate seizure and non-seizure classes. Clear? So this is the result will come in the form of probability when you will use Kruskal-Wallis test, which can use for 2-class classification problem. So if the probability is less than 0.05, then you can say that that particular features or band is useful. Otherwise, this features and band is not useful. So like here, the first 4 IMF we can use, other 4 IMF up to 5 to 8 we cannot use for discrimination purpose. Clear? So this is for only 2-class classification problem. If you are going for multi-class classification problem, then we have to go for post hoc analysis. That is the difference that can use for multi-class classification problem. For 2-class, we can use this one. Now after that, we can say that these features are useful for first 4 bands, but still we don't know which particular band will give higher accuracy in machine learning algorithm. Clear? So what we will do, one by one we will process and we will find out which particular band is useful. Now we can use some machine learning algorithm for automatic classification. Till now we have done discrimination. Now we will go for classification of any machine learning algorithm for classification of seizure and non-seizure signal. So here I have taken an example of LSSBM, least square support vector machine. Why least square support vector machine? There are plenty of machine learning algorithms. There are so many machine learning algorithms. Then why I have chosen a LSSBM? The reason is other algorithms, all points are, the points means the data we are using, like beta M, beta FM, we will use as input now for train this classifier. So the data, now the data is the features. Okay, so now the features, whatever features we are using in the machine learning algorithm, so other algorithm like KNN, ELM, there are so many machine learning algorithms. So here the support vector only the features which are nearly in the both the classes are useful for decision making. Others points are not useful for making a hyperplane. We will discuss, then you will understand what I am saying. What I am saying, in the least square support vector, we need to find out some support vector, and the decision to make these hyperplane only support vector is responsible. So your accuracy will become high. It's also depend on the kernel function that we can, how we can develop the new kernel function, that also we will see, and what are the problem in support vector, that also we will discuss. So initially we can understand that there is a one classifier which is LSSBM classifier. Clear? In this particular classifier, there are some inputs. What are these inputs? These inputs are feature set. Clear? What are these feature set? In this, we will talk about this. The example we are taking, the same example we will quote here. So now here, what will be the input? So like we have beta AM and beta FM. Clear? So like, for example, for seizure we have 100 signals. For non-seizure we have 400 signals. Clear? So now our feature matrix for seizure class, we have a features matrix 100 by 2. For non-seizure class, we have features matrix 400 by 2. What is this 2? These 2 known as features. Here I am using 2 features. If you use 4 features, then the matrix size will be 100 cross 4 or 400 cross 4. Clear? So this is known as input training set. Clear? This is for one class, this is for other class. Clear? Now, what do you mean by output training set? Output training set depend on your classifier. Like here, I am using LSSBM. So one class known as one class, another is known as minus one class. Clear? Some classifier known as binary classifier where you need to take 0 and 1. Depend on the classifier or programming what you are taking. So like for this LSSBM classifier, we have to take 1 and minus 1. 1 is belongs to seizure class, minus 1 belongs to non-seizure. So that matrix 100 cross 1, once we need to put, and 100 cross 1, sorry, 400 cross 1, minus 1 we need to make a one matrix. Clear? So that is known as output training set. Got it? One is known as input training set, second one is known as output training sets. So these are the input of LSSBM. Clear? Now the kernel function will be the input. What do you mean by the kernel function? Kernel function means whatever hyperplane we are making. Hyperplane क्या कहलाता है? Hyperplane means the boundary. That will take decision कि from that boundary which particular portion is belonging to which particular class. So based on that hyperplane, based on this kernel function, your boundary will decide whether this kernel function is linear, then your hyperplane will be linear. If it is polynomial, then your hyperplane will be polynomial. It is RB radial basis, means like a Gaussian, then your hyperplane will be Gaussian. Or based on the kernel, your hyperplane will be decided. Clear? Got it? Anyone, if somebody is listening, then please. Hello? 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 Dr. Sachin? Sachin? Hello?
Yes, sir. Yes, sir.
It's visible?
Now it is stop, sir.
Okay, just a minute. Now it's not visible.
Not visible, sir. Now it is presenting, sir. Now I can see.
Actually, I think it is looking like one-sided, so that's why I thought that, yeah.
Yes, sir. Yes, sir.
Yeah. Now after applying these, after deciding these training input sets and output set, then we need to decide this kernel function. Clear? Then we need to also select the kernel parameter. Clear? After giving these inputs, this LSSBM classifier, how there are three things. One is all machine learning algorithm having a three basic thing. One is known as training. Second is known as learning. Third one is known as testing. Clear? How these three things we can understand. So very easy way, I will try to explain you what do you mean by the training. Training means like you are teaching some course, that is known as training. Clear? You are telling your student ki what is the subject, what is the insight of that subject, and you are teaching that course. So that is, you are given a training to your student. Okay, whatever you are saying, the student will think ki this is correct. Clear? So that is known as training. Whatever you are teaching, that is known as training. Clear? Now, after that, what your student is understanding, what he has learning, how he has understanding of your subject, that is known as learning. Okay. Now, after that, through exam, you are going for testing. Clear? Through exam, you are trying to ask some question based on your subject. Then you will say ki whether this is your based on you need to check performance. Then you can say that whether the student, what is the performance of the student. Same thing in the machine learning algorithm. You have to train your data. Based on that, your classifier or machine learning algorithm will make a hyperplane. Hyperplane means boundary based on the training. If training is not correct, then अगर टीचर ठीक से नहीं पढ़ा रहा है, then it may be a difficult. It is a problem. So if your training is correct, then only you can think your learning will be perfect. If there is some problem in a training, then it may be might be a problem in a learning. Clear? So if your training is good, then of course your learning will be better. Then based on that, you can go for testing. Then testing will give you the performance parameter. Clear? Now, if your data is 100%, then how much data you can use for training? This is the again one question. Clear? From which data we will train our data? So what people are doing in a day, for literature you can do anything. People are given a wrong interpretations also. But if you want to develop good diagnostic system, good models, and you want to prove that, and also you want if you develop this particular system into a hardware, then it will work fine. So what you have to do, you have to train, you have to use cross validation technique. Otherwise your model will be overfit or unfit. अब overfit मतलब ज्यादा trained हो जाएगा, unfit means कम trained होगा. So for this purpose we have to go for cross validation. Cross validation, how this will work? So now after that there are so many cross validation, but right now the 10 cross validation is very good technique to find out to check the performance of your classifier or your method. अब how 10 cross validation is used? 90% of the data you will use for training and 10% data you will use for testing. Clear? Now in a first time, second time, other 90% data you will use for training, 10% you will use for testing. So what you need to do? You need to divide your data into a 10 parts. 9 parts you use for training, 1 part you use for testing. Then different 9 part you use for training, then different. So this way your whole data will check in 10 repeated process. Then you can say that whether your method is good or whether your method performance is good or not. Clear? Got it? So 10 cross validation you have to use. Sometimes people use 5 cross validation. You can use it, but your result, you have to evaluate your result with, because when your signal, your data is modeled by all the variability, then you can say that your data is correctly trained. So what we are trying to do here, we are trying to check all the data through 10 cross validation. Clear? Now the problem is which particular kernel function we can use in the LSSBM classifier. You can use any of the kernel parameter, but we have to find out the performance parameter, or based on the performance parameter, you can say that which particular kernel parameter, kernel function or parameter is appropriate for your data. Because if your input is changed, your entire process will change. Clear? If your features is changed, then everything is changed in this classifier, because it's a data dependent. Whatever data you are given in the training, based on that it will perform. What is my point? So the data you are providing, based on that you need to fix these things, kernel function or kernel parameter. Clear? Now how this LSSBM classifier works, so we will see. Suppose for example, like it's a very simple mathematical problem. Machine learning algorithm works in a mathematical problem. So like this is your complex plane. Okay, now this is your beta am, this is your beta fm, for example. Clear? So this is belonging to +1 class, this is belonging to -1 class. Clear? So this is the training sets. When you are training your model, then you are saying for this particular, suppose this is for a condition for first time. Now you are saying this is the value of beta am and this is the value of beta fm for first signal, and it's belonging to one class. Clear? Same, you are modeling all the points. This is 2D, so you can visualize. This is the beta am axis, this is beta fm axis. Now this is belonging to one class, now this is belonging to -1 class. Clear? Now, if you are using linear, because your data, it's like it can be linearly, it can be classified. Clear? But in real, this is just a hypothetical or a very basic problems. It can be linearly classified. But real situation, it cannot be. If it is classified linearly, then simple thresholding method also work. But if you see the real situation, then I will show you the real situation. So like if your data is linearly classified, then this hyperplane you can make linear classify. Clear? So this way you can make linear classify. Only support vector with, by I already told you. Why LSSBM classifier I have used? Because in LSSBM classifier, only the support vector will be useful for decision making. Other parameter will not useful for decision making. So that's why we need to choose some support vectors. So it will reduce the complexity of the system as well as it will improve the accuracy of the system. Clear? So like for example, there are so many kernel functions. So this is known as machine learning techniques. So there are a few properties of LSSBM classifier like flexibility to choosing the similarity functions. Okay, this also useful for it can also useful for handling a use features space. If your features space is larger, then also LSSBM classifier will be useful. The complexity does not depend on the dimensionality. Means suppose your feature set having a 20 features you are using. Okay, so your complexity will be same. Like if you are using 2 features, 3 features, 10 features, then also your complexity will be remain same in LSSBM classifier. But other classifier complexity will change. Okay. Next is overfitting can be controlled by the soft margin algorithm approach, and the feature selection also are one of the important property in LSSBM classifier. Weaknesses: first, it is very sensitive to noise. For like a small number of mislabeled data. Suppose in a training, if your data is mislabeled, then it will be a problem. Okay. Second, LSSBM classifier only useful for 2-class classification problem. Okay. If you want to use for multi-class, then you have to use different type of architecture. Architecture means it is always used 2-class, but how it will work? Like suppose your class is 3-class classification problem. So what you need to do? You need to find out the classification first in between 1 and 2. Then you need to find out in between 2 and 3. Then it will make a hyperplane which can final hyperplane which can classify these 3 different classes. So one by one you have to do. So it will make a common hyperplane which are applicable for classify all 3 different classes. So this is basically a for 2-class classification problem. It can use for only 2-class classification problem, but by using different architecture, you can also use for multi-class. Okay. Then there are some issue like choice of kernel function, kernel parameter selection also a problem. Previously it was problem, now it is a little bit solved. How it is solved, that I will tell you how we can solve this problem. So like here there are different type of kernel functions. So like here I have used polynomial kernel function and radial basis function. So polynomial kernel function, which can be used, this degree we need to fix any polynomial. This L is known as degree. That degree is known as kernel function of kernel parameter of this polynomial kernel. So we have to check whether we need to fix 3, 5, 7, which particular degree your hyperplane given a better accuracy. That we need to check it by manually. Clear? Same. In a radial basis function, there is a one parameter which is known as sigma based on the control width. This is the controlling the width of this RBF function. This we need to find out. What will be the sigma kernel parameter value we can fix for better classification to achieve better classification performance. Clear? But still, these are the non-linear classifier. Clear? Polynomial is also non-linear classifier, or RBF is also non-linear classifier. But if you are going for multi-dimension, then all these kernel function also are problematic. If you are going for multi-dimension, then the wavelet function, which is useful for multi-resolution property. So I have developed Mexican head wavelet kernel function and Morley wavelet kernel function for LSSBM classifier. Okay, because we already discussed wavelet having a multi-resolution property. That property also we can utilize for selection of kernel function or develop new kernel function. Like here I have used Mexican network wavelet, Morley wavelet kernel function. So based on that, here also we need to select some parameter. Clear? But nowadays, the selection of parameter is not a big problem because due to our system is very computationally efficient, so we can use some optimization problems. That further we have done it. Optimization problem means if you want to select some parameter or any problem which have multiple solution, or you want to find out exact solution, which particular solution is the best. For this, you can utilize optimization problem or optimization algorithm. Like some of the optimization algorithm like ABC, genetic algorithm, PSO. There are plenty of genetic algorithm. There are plenty of evolutionary algorithm which can utilize for better selection of these parameters. Okay. Now, based on that, complete automatic LSSBM classifier we can make it, but it still is a problem. Kernel parameter, kernel selection, kernel parameter you can select by using this, but kernel you have to select as a input now. Clear? So you have to give as a input your feature set and kernel function. So for different kernel you need to check whether, now these are the performance parameter which will give whether your algorithm is good or not, like accuracy, specificity and sensitivity. These are the parameters which will give you the idea whether your classifier or whole method is working properly or not. So these are known as performance parameter. Clear? Now, after that, you can see here the polynomial kernel, RBF kernel, Mexican and Morley kernel. These four kernel I have used with different first four IMF. Clear? So like here, Morley wavelet given a better classification accuracy, 99.5 to 100. Why this variation is coming? Because we are using 10 cross validation. So 10 accuracy will come. So there are various ways. Either you can take average or you can take range. This is our range for our algorithm. This is the range of accuracy. So like I have used 99.5 to 100. So this is the minimum accuracy. This is the maximum accuracy. Clear? So for cross validation, you can use some statistical analysis also, like mean plus minus standard deviation you can use. Okay, so now this way we can conclude Morley wavelet of LSSBM classifier with second IMF, beta AM, beta FM given a better classification accuracy for identification of seizure or classification of seizure and non-seizure EEG signals. If you see the hyperplane is look like this, because this is two-class classification. Sorry, two features we are using. So two-dimension we can plot. If there is a three-dimension or multi-features we will use, then the plot we cannot find out. This features plot we cannot find out if your features having a multi-dimensional. Because it is two-dimensional, so I can plot, I can see how the features is plotted in this plot, how it will look like. Okay, so like this is for non-seizure class and this is for seizure class. This is for second IME. So once the data is coming in this particular area, your beta M, beta FM is coming in this particular area, then you can say that the person having a seizure. Otherwise, person is belonging to that particular patient belonging to non-seizure class. Clear? This only this features matrix you can visualize, features space you can visualize if you have only two features. Clear? If more than two features, then it is very difficult to plot it. Because 4 dimension you cannot plot. Sometimes 3 dimension also you can plot, but it is very difficult because 3D sometimes it is get difficult. But 2D you can easily plot features space. Okay. Now after that, I have compared our result with all the papers which can use for the same database or same problem they are taken. So this can be utilized. Now after that, what people are doing after developing this algorithm nowadays, previously people are just trying to publish papers. Now that things are changed. Now everybody is looking for product. How this can be developed as a product? So now what people are thinking now? People are thinking for either Raspberry Pi or some other like Arduino Uno, Raspberry. There are different type of hardwares or processor are available where this code can be done by some other language like Python you can use, some other language also you can use, and you can make the hardware of this particular problem. Okay, like previously people are thinking we can develop software, but now the hardware is also as much as stronger like a software and very cheap also. So now people are trying to develop this type of hardware through Arduino Uno, Raspberry Pi. They are trying to dump this code. After developing this algorithm or analysis, what is our input? This will become one black box where there is a hyperplane that we have already seen, features space. Now whenever external input will come, input means EEG. Now after that there is an algorithm which can find out second IMF, then it will calculate beta M, beta FM. Now after that this beta M, beta FM can be plotted in this particular features space. Then it will tell you whether it is belonging to one class and belonging to minus one class. Clear? Got it? How this will work? After, even though I am also trying to develop for some of the cases, I am also trying to develop some hardwares for biomedical applications, but not for seizure. For other applications I am trying. So this way it will work. After analysis or completion of the this particular algorithm, also people can be developed hardware. Clear? So this is based on the decomposition technique. Clear? Now after evaluation of machine learning, nowadays is everybody is moving for deep learning. Clear? Now how people are working on the deep learning? Clear? So as now deep learning, for deep learning there are two type of models. One is known as one dimensional, another known as 2D deep learning. Most of the deep learning algorithm, they are taking image as an input. Got my point? What they are doing, they are taking a image as an input. Clear? Now if you have one dimension means if you have a signal where the that signal is function of time. Clear? So now, and for this deep learning algorithm, suppose image is the input, then what we are doing, we are converting this FT into a time frequency image, or time, by using time frequency analysis technique, we are trying to develop this time frequency representation as a time frequency image. Clear? Now what is the benefits of time frequency image? Because this signal is time domain. Clear? Here we have only time domain information, but if we will use directly 1D CNN, we can directly we can use 1D here in CNN, but it will give better or not, that we cannot justify it, or we cannot say whether it will give better accuracy. But here what I am doing, this we are converting into a time frequency image by using some time frequency representation, by using SPWBD or some other distributions also. Then it will convert as a image. Then this image can be directly used as a input to any machine learning algorithm or deep learning algorithm. Like in the deep learning, there are few models which is already available, like LXNet, VGG16, ResNet 50. We also developed our configurable CNN. Clear? For emotion classification. Clear? What is my point? We can also our model, we can, based on our application, we can also develop our own CNN based on the requirement, based on the complexity, based on the many things. There are certain parameters. Based on that, you can develop our own CNN. So one of my student has done it recently. He has submitted his thesis, and the work is, this particular work we have published in IIIT Transaction of Neural Network and Learning System. So like here we have used for emotion classification. So previously we do not have any data for emotion classification. So we have developed our own database. So what we have done, we have shown some videos to different type of subjects. Then we ask what are the feeling. Based on that, we have done some experiment. Then we find out some recordings of EEG. Then these recording is belonging to 4 different classes, like sad, fear, then relax, then happy. So there are 4 different type of classes. Then based on that, we have developed our own experimental setup or database. So in our database, we have taken a subject from 22 to 25. Audio video stimuli we have used. Sampling frequency was 256. 20-second data has been recorded. The data has been recorded from the bipolar montage. Bipolar means when you are taking a EEG, so there are 3 type of montage. One is known as monopolar, second one is known as bipolar, third known as common reference montage. Means here we are in 10-20 system, like here, just I will show you. Like this is known as 10-20 system, where we need to put the electrode, and particular portion of the brain is responsible for particular activity. But we don't know for which particular activity, which particular portion is responsible. So what we have done in our experiment, we have made a bipolar strategy or bipolar montage. So we got 16 signal. Still we cannot say that which particular signal is useful for emotion classification. But after some of the experiment analysis, we find out, even though in the literature also it is available, the frontal region is more responsible for emotion. Okay, frontal region, the emotion is initiated from the frontal region of the brain. Okay, so we have find out the same thing also. We have done some experiment, we have developed some algorithm, then find out which particular portion, which particular signal is given a better accuracy. Based on that, we have concluded in previous papers. Now in this particular paper, what we have done, we have, based on the previous experience, frontal region we have used as input. Then we have converted our signal into a time frequency image by using SPWBD. Then this we have done for different type of deep learning algorithm for 4 different classes. Then this is look like for different emotion condition. This is SPWBD, how they are looking like. So by visual inspection also we can see that there may be some difference on these images. You can see here, like relax and fear is looking different, and the relax and happy is looking different. So all 4 type of plot you can see here, and they are looking different. They have different type of frequency component. So based on that, we done some statistical tests. Then we find out that this particular time frequency representation we can use as a MOH to train our model. Then we have developed our configurable CNN, where we have used two max pooling layer, 2 fully connected layer, and softmax layer, and we have selected these parameters in such a way so that we are getting a higher classification accuracy. So like LXNet, we have done it through LXNet, then through ResNet 50, then VGG 16, then configurable CNN. For configurable CNN, we are getting a 93% accuracy. Clear? After that, in this particular CNN also, we find out some difficulty how to select the parameter. Manually, we have selected parameter. Then through evolutionary algorithm, we have modified this CNN so that everything will be automatic. Now, based on that, we are trying to develop some hardware. So like in previously algorithms also, we have compared our work and we have published this work. And based on that, we can draw some conclusion. Signal processing technique can improve the accuracy and efficiency of any healthcare system, which is non-invasive in nature. It also limitless prediction about the revolution for the improving the quality of healthcare, and dramatically it is reducing the cost of healthcare system. Like also in a real situation, like people are trying to develop the non-invasive diagnostic system for diagnosis of COVID also through CT scan, through MRI, people are trying to develop. Okay, so this is like signal processing technique can improve the accuracy, and machine learning algorithm can they can also improve the accuracy, as well as they will give a automatic things. They will provide a automatic detection, automatic diagnosis. So this way we can improve the healthcare system. But in a still future scope, we are, as I already told, if we are going for hardware, so the energy efficient algorithm we need, which can be active for a longer time. The security is also one of the big challenge because the data is private. Now, as we already facing a problem for collecting a data. Now, maybe in the new education policy, what they are trying to develop medical and engineering hospital, like medical hospital and engineering institute in the same place. So maybe people will, what is the problem in our country? There is a huge gap in the medical side or engineering side. This is a big challenge for our country. So if both team will come together, then we can only develop the hardware, because somebody know the hardware, somebody know the technology, but they don't know the medicals. Somebody know medicals, then they don't have time to provide their outcomes for the technological person. So this is a huge gap in nowadays in medical and technological institute. So if this gap will reduce by a new education policy, then it will be a great opportunity for India. Then the third problem is real time. So like the machine learning algorithm, they are for offline, they are working fine. But when we are going for actual real time processing, then it may be a difficult, because real time process we required some efficient hardware which is computationally efficient. So this is the future trend. These are the references. Currently, we are working for a diagnosis of seizure, sleep stage classification. We are also working for identification of focal and non-focal area, which can use by the neurologists where the surgery is required. We also working non-invasive methodology for alcohol and non-alcohol detection. Yeah, emotion classification already I have told you. For EMG, we are working for ALS and normal EMG signal and diagnosis of neuropathy and myopathy. One group is also with us working for ECG signal like QRS complex detection, normal, abnormal beat classification. So this is current research work going in our lab. Thank you. If you have any question, then yeah.
Any question from the side of participants? You can also write in the chat box.
Anybody, if you have any question, anything, then you can ask.
If no question, then we will end this session. Okay. No question. Sir, thank you for giving this informative session and giving the detailed explanation about the biomedical signal processing and exploring different problems in the relevant field, whether related with the normal machine learning and deep learning. So I think with this talk, the participants will able to explore the new areas in the field of biomedical signal processing. So thank you, sir, and accepting our invitation from your busy schedule. Thank you, sir. So dear all, yes, sir. Yes.
Thank you, sir.
So dear all, this is the end of this FDP, and I like to thanks all the experts who have given their time for this FDP, and I also like to thanks all the participants who have joined and registered for this FDP. I like to thanks also my university, Delhi Technological University, for giving the financial support for this FDP. I also like to thanks my colleague and coordinator of this event, Dr. Rohit Kumar, Dr. Anukul Pandey, Dr. Pankaj Zaiya. And once again, I thank you for all of you being a part of this FDP and giving your precious time since last 5 days. And I hope this event will help you to find new research areas in the relevant field, and your such enthusiastic participation will encourage us to organize similar events in the future. And soon we will share your certificates on your registered mail ID. If you have any discrepancy or error in the certificates, so please contact on the detail given the brochure. So thank you all of you. If you have any query regarding the certificate and any other thing, please let me know. We will share your certificate maybe try to today or by tomorrow. If there is any error in the name or institute, you just let us know. Okay, thank you all of you.